Okay, to find the equation of a line, we need the slope, and we've learned by now, I hope, that to find the slope, we need the derivative. So if we write y equals x times the square root of x in its exponential form, we have y equal x to the 3/2. Find its derivative, and it would be 3/2 x to the 1/2 using the power rule, which is 3/2 times the square root of x, and we need that slope at the point 1, 1. So we have x equals 1 at that particular point. We plug in a 1 to our derivative and we find out that the slope of the tangent line is 3/2. So we use our point slope formula, y minus y1 is equal to 3/2 times x minus x1, and do the arithmetic, and we find the tangent line has the equation y equals 3/2 x minus 1/2. Now, to find the normal line, we just said before that normal meant perpendicular, and we know from algebra that perpendicular lines have slopes that are negative reciprocals. So if the slope of the tangent is 3/2, the slope of the normal line is negative 2/3. So plugging into our point slope formula, y minus 1 is equal to negative 2/3 times x minus x1, because we're finding the normal at the point 1, 1. And doing the algebra, this simplifies to the normal line having an equation of y equals negative 2/3 x plus 5/3. And this would be what the equation's graph looks like. X times the square root of x is your blue line. Your tangent line is the pink line, and then the normal line is the perpendicular at that same point. When new functions are formed from old functions by addition, subtraction, or multiplication by a constant, their derivative can be calculated in terms of derivatives of the old functions. In particular, the following formula says that the derivative of a constant times a function is the constant times the derivative of the function. So you can take the constant outside the derivative, go ahead and find your derivative, and then multiply by the constant. So in this particular problem, if I take the derivative of 3x to the 4th, that's the function x to the 4th, times the constant 3, then I can take that constant out and find my derivative of x to the 4th, which is going to be 4x cubed, times my 3 that's already out there. So that would give me 12x cubed as the derivative of 3x to the 4th. In the next problem, we have find the derivative of negative x. So I would take the negative 1 times the x outside the derivative sign, and the derivative of x is simply 1 times negative 1 is just negative 1. The next rule tells us that the derivative of a sum of functions is the sum of the derivatives. We saw a similar rule with limits. If I have the derivative of a sum of functions, then I can take the individual derivatives. And that is true if both functions are differentiable. The sum rule can be extended to the sum of any number of functions. It doesn't have to just be 2. I can add any number of functions, and when I find their derivatives, I can just add the individual derivatives. And if you're thinking ahead, then you see how this might apply using the power rule and using this rule to get the derivative of a polynomial. And if we think of f minus g as f plus negative 1 times g, then you see that it would be pretty easy to prove that the sum rule and the constant multiple rule will tell you that if you subtract two functions and you want to find their derivative, you can subtract the individual derivatives. So the constant multiple rule, the sum rule, and the difference rule can be combined with the power rule to differentiate any polynomial. For example, if I want to differentiate x to the 8th plus 12x to the 5th minus 4x to the 4th plus 10x cubed minus 6x plus 5, that would be like 1, 2, 3, 4, 5, 6 individual functions that I'm adding together, so I can differentiate each one of them separately. So I would find the derivative of x to the 8th using the power rule would be 8x to the 7th. The derivative of 12x to the 5th using the power rule and the constant multiple rule says that would be 12 times 5, which would be 60, x to the 4th. And the derivative of 4x to the 4th would be 4 times 4x to the 3rd, so 16x to the 3rd. The derivative of 10x cubed would be 10 times 3x squared, so 30x squared. And the derivative of 6x would be 6, and the derivative of 5 would be 0. So here is the derivative of that polynomial. The next problem, find the points on the curve y equal x to the fourth minus 6x squared plus 4 where the tangent line is horizontal. So see if you can work that before you look at the next video.